All right, guys. Let's look at these here. Our properties of exponents. None of these are new. We've worked with these in Algebra 2. You've done them in Algebra 1, geometry. We've had them in some way, shape, or form. Product of a power. All it's saying is if we multiply two things with the same base together, we add the exponents. X times x is x squared. We add the exponents together. Powers of a power. 3 to the 5/2 to the second. When we have a power of a power, those exponents multiply. We've seen that. Power of a product. If we have two things being multiplied together and they're both to an exponent, we apply that exponent to both terms. Negative exponent. If the exponent negative, we move it from the top of the fraction to the bottom, or bottom to the top. Now, most everybody's favorite exponent property is the zero exponent, because anything to the zero power is? One. This here is saying that we can't have 0 to the 0. 0 to the 0 does not have an actual answer. It's not 1. We can do 0 to any other power, so 2/3 to the 0 is 1. Doesn't matter what the base is as long as it's not 0. Whenever we put it to the 0 power, it reduces to 1. Our quotient of powers. If we divide like bases, we subtract the exponents. And power of a quotient, if we have two things being divided to a power, we can apply that power to the top and bottom. So these are just our properties of exponents, and we've seen these in some way, shape, or form over the last few years. Now, we're not going to worry too much about simplest form at this point, because that will come into play more tomorrow. But we want to simplify these terms. 7 to the 1/4 times 7 to the 1/2. Since we're multiplying like bases, we will add the exponents. When we multiply like bases, we add the exponents. So our exponents are 1/4 and 1/2. So we're going to add 1/4 and 1/2 together to get is 3/4. Because if we're adding two fractions together, we would have to get the bases to be the same, or the calculator will do it for us. Because we can do 1/4 plus 1/2 in the calculator, and it will tell us it's 3/4. So our final answer is 7 to the 3/4. We're not trying to approximate its value. We just want to simplify the expression. If it reduces, we'll reduce it, but here 7 is prime. So 7 to the 3/4 is our final answer. If we wanted to check it, we could. Because I could grab the calculator and say 7 to the 3/4 is this here. Our original one was 7 to the 1/4 times 7 to the 1/2. Kind of hard to see, but we do get the exact same decimal number, so those are equivalent. So our answer is 7 to the 3/4. Questions on this here? B, 6 to the 1/2 times 4 to the 1/3, all to the second power. Well, 6 and 4 are not like bases, so we can't use our product. But we do have these all to the second power. Product of a power, we can apply that power to both. And our powers of powers multiply. So our 6 to the 1/2 squared would be 6 to the 1/2 times 2 times 4 to the 1/3 times 2. Powers of powers multiply. Our 1/2 times 2 would indeed be 6 to the 1st, or just 6. 1/3 times 2 is 2/3. And that's as far as it goes, because our 4 to the 2/3, that third in the bottom, the 3 in the bottom of that fraction is a cubic. We'd have to find something that times itself 3 times. That would give us 4, which doesn't work. We could do 2 times, because our 1/2, our square root does work with 4. Cube root does not. So 6 times 4 to the 2/3. That's it, as far as we have to take it. Questions on A and B? Let's look at C. Now, there's different ways we can look at C. The one thing we notice with this here is that the 4 and 3 both have the same exponent of 5. So one way we can look at this and do this is, for simplification's sake, because I can pull that 5 back to being an exponent, our powers of a product. Because since they both have the same exponent, we can move it out. Because what does that leave inside? Well, what is 4 times 3? Because they both have the same exponent, we can pull it out, back up into an exponent, and do 4 times 3. Questions on how we got to here? Powers of powers do what? Multiply. So what we have is 12 to the 5th times negative 1/5. Now, really, we have a third one in here. That third one is 1, because the exponent immediately attached to the 12 is 1. So we could say 1 times 5 times negative 1/5, but 1 times 5 is, well, 5, yes? So that doesn't add anything. But what's 5 times negative 1/5? Mm-hmm. Questions up to this point? Yeah. And the last thing we need to do is make sure that the exponent's positive. And to do that, we move it from the top of the fraction to the bottom, or we can flip it. Questions on C? You see how we did that? Now, again, there is another way we can do it. We can do exactly what we did on the previous.
And on B, when the answer is 6 times 4.
Now, on B, we just applied that exponent to both. Powers of powers multiply, yes? So that would give us 4 to the 5 times negative 1/5. That's being multiplied by 3 to the 5 times negative 1/5. This is just another way to do it. Now, our 5 times negative 1/5, like we saw with 12, is just 4 to the negative 1. Same with 3. We'd have 3 to the negative 1. You see how that works? Well, to make these exponents positive, we would move the 4 from the top of the fraction to the bottom, and the same with the 3, giving us 1 over 4 times 3. Well, that is 1 over 12. We get to the exact same spot. Different ways to do it, but both will get us to the same answer. Does that make sense? If the one we did first makes more sense, do it. If the other makes more sense, do it. You just got to pick one and do it. No matter which. Questions on A, B, C? We ready for the next two? Okay. D. 5 over 5 to the 1/3. Here our bases are the same, so we can subtract the exponents, because again, the main reason we're doing any of this is 5 to the 1/3. That's really saying that we're taking the cubed root of 5. We can't leave it in the bottom of the fraction. Now, what's our exponent on top?
0. Just 1.
We don't have an exponent written, so it's understood to be 1.
It does the same thing. It's actually up on top.
So, since the exponent on top is 1, we're going to do 1 minus 1/3. Exponent on top always goes first. Exponent on bottom goes second. Now we need to do 1 minus 1/3, which is
There's just one. Oh, okay.
1 minus 1/3. We can't type the whole thing in, but I can type 1 minus 1/3 into the calculator. Is 2/3. That's it. Tim, questions on A through D? Are you ready for E? So we have division again. But this time, the bases are not the same. We have 42 and 6. But they do have the same exponent attached to both 42 and 6. Yes? We can. Because they both have the same exponent. And those 42 and 6 divide evenly. Yeah. We can do like we did on C. And take that exponent out and reduce. Because 42 over 6 is 7. Because again, just like the previous one, we don't want this fractional exponent in the bottom of a fraction. We cannot have a fractional exponent in the bottom of a fraction. And because 42 over 6 does divide evenly, and they both have the same exponent, we can take that exponent out 1, which would give us 42 over 6, all to the 1/3, all squared. 7 to the 1/3 squared. Powers of powers multiply.
2 over 6.
Questions on this here? So we feel good with everything so far? Possibly. Hopefully the feedback on the videos has been better. So they're not new. I just started putting the mouthpiece down. Because I think it still catches my voice quite well. You just don't get me breathing. Because the mic always sat right near where I exhale, so it's picking that up. So hopefully you won't hear it at all now. But do we feel comfortable with these here? The rest of this note sheet is just doing more of them. So our next one, 2 to the 3/4 times 2 to the 1/2. Since the bases are the same, we can add the exponents. 2 to the 3/4 plus 1/2.
Oh, plus.
So 3/4 plus 1/2, we can do it in either calculator. Yeah, 3/4 plus 1/2. We can't do 2 to the power, but we can do the 3/2 or 1/2 and 3/4 because we can add the two fractions together. Number 2, 3 to the 1/4 or 3 over 3 to the 1/4. Since we have like bases and we're dividing, we would subtract. Now, since the exponent on top is not given, it's understood to be 1. So we do subtract 1 minus 1/4 is when we divide like bases, we subtract the exponents. So it'd be 1 minus 1/4. Now, if the exponent on top had been 2, 3 to the second, or 3 to the 1/2, we do 1/2 minus 1/4. We'll get this here. Number 3, 20 to the 1/2 over 5 to the 1/2, all to the third. Right, because our 20 over 5 would be 4, 1/2 to the 3, yes? What's our 1/2 power? The same as in a radical form. So if I rewrote that as a square root, well, it'd be a square root, wouldn't it? 1/2 is our square root. Can I take the square root of 4? This is the first one that we had to actually does simplify. Now, because I believe you had 4 to the 3/2. Yes?
Oh,
That is 8.
so let's check it. Well, I did that in my head. I cut 3 or 4 steps out.
Because here, 4 is 2 squared. Because that's what 4 is. 4 is 2 to the second power. So if I plug it in here, really what we're saying is that I have 2 to the second power to the 1/2 to the third, because that's what 4 squared is. Now, for the most part, this means not a whole lot. But 2 squared to the 1/2, well, that'd be 2 to the 2 times 1/2, which is just 2 to the third, which is 8. We kind of see how that works out, yes? Now, on B, we did have 4, yes? But the bottom of the fraction is what? 3. So will that 2, will 4 reduce by this here? Well, no. Because I could do the same thing, say 2 squared to the 2/3. Well, that's just 2 to the 4/3. Did it get any simpler? No. So we just leave it as 4 to the 2/3. Because that base here for this fractional exponent was 2, it reduced with that 4. That's why it's simplified.
So it's a factor of the
It's a factor of the power.
Okay.
Because here, the power of 4 was 2 squared. That second power and that 1/2 are what simplified.
So if that was 8 and it was 4, would it?
If it was 8, not really, because 8 is 2 to the third. It's not a square. It wouldn't do much. 16 would, because 16 is 4 squared. Then it would simplify.
Okay, I see that. That's a lot easier.
Yeah. Number 4, 5 to the 1/3 times 7 to the 1/4, all to the third power. Well, powers aren't the same, so we need powers of powers. So 5 to the 1/3 times 3 times 7 to the 1/4 times 3. What is 5 to the 1/3 times 3? Be 5 to the almost 1/3 times 3 would be what? It'd be 1. 3 over 3, which is 1, so it'd just be 5. 7, 1/4 times 3 is 'cause powers of powers multiply. Like bases, if we're multiplying like bases, we add the exponents.
What is multiplying with the numerator? 1 times 3, 1 times 7.
Mm-hmm.
I didn't even.
Fractional multiplication, we multiply by the tops. Tops with tops, bottoms with bottoms. Mm-hmm. Questions on these 4 here? 3 to the 1/2 times 3 to the 3/2. Since we're multiplying like bases, we
4.5 times 3.
add the exponents. When we multiply like bases, we add the exponents. Powers of powers, we multiply the exponents. Well, 1/2 plus 3/2 is what? Almost.
3.
Because the bases are already the same, yes? So we're adding the exponents. 1 plus 3 is?
Oh, 4, 2.
Which is?
Oh, we can do the denominator the same? Okay.
Yeah. Yeah, 3 squared, we can do that nicely, is 9. Yeah, so 1/2 plus 3/2 is 4/2, which is 2. And 2 squared is 9. 7 to the 2/3 times 7 to the 1/2. Since we're multiplying like bases, we would.
The 2 over 3 and 1.
We'd add the 2/3 and 1/2. Again, you can do this in a calculator. 1/2 plus 2/3 is
5.
1/2, 2/3.
Oh.
1/2 is 1.
2/3 plus 1/2 is 7/6. I had that wrong. Because really, when we combine or add fractions, we get the bases to be the same. Basically, we get the denominators to be the same, and then go from there. So here, the first thing that we could get both 3 and 2 to be is 6. Get the numerators and add. Or we can do 2/3 plus 1/2 in the calculator, and it will do it for us. And plug it back in. Questions on this here? 10 to the 1/2 divided by 10 to the 1/4. Since we're dividing like bases, we subtract the exponents. So we're going to do 10 to the 1/2 minus 1/4. Well, 1/2 minus 1/4 is 1/4. Questions on any of these here? Four to the 3/2 squared. So it'd be 4 to the 3/2 times 2. Well, 3/2 times 2 is 4 to the 3rd, is it, which is, yes, 64. Questions on these here? We feel pretty comfortable with all these? All right. If that's the case, let's do one more, and then we'll call it for today. I want to look at B, which should be almost the last one. 27 to the 1/3 times 6 to the 1/4, all squared. Well, 27 to the 1/3, what times itself 3 times is 27?
3.
3. So it works out this one here, we could simplify from the get-go. This leaves us with 3 times 6 to the 1/4. Powers of powers multiply. So we'd have 3 squared times 6 to the 1/4 times 2. Now what is 3 squared?
Oh, that's 9. Would it just be?
Because our 3 squared would be 9. 6 to the 1/4 times 2. Well, 1/4 times 2 is 1/2. So it's 9 times 6 to the 1/2. If we could reduce the 6 to the 1/2, we would need to find a number that multiplied by itself to give us 6. And it'd be a decimal.
I always wanted to buy that.
And that's it.